Alright, here goes an explanation of solving exponential and logarithmic equations. So remember, exponential and logarithmic equations essentially are reverse processes of one another. So in this example, we have an exponential equation, the variable's in the exponent, and we're going to take the log of both sides to help us out. If this said 2 to the x equals 4, we would just kind of look at it and think about it and be like, oh, 2 squared equals 4. And we would know that. But that's not what it says. And if it said 2 to the x equals 8, we'd be like, well, I know that 2 to the third power is 8, so x equals 3. But that's not what it says. So we know it's something in between 2 and 3. So here's how we solve. 2 to the x equals 7, and what we can do is if we take the log of both sides, so this could be common logarithm, meaning base 10, or we could use natural logarithm. But the bottom line is that the exponent can come out as the coefficient, so we end up with x times log 2 equals log of 7. We can then divide, so we get x equals log of 7 divided by log of 2. So you should be doing this on your calculator. Let's see, log of 7 divided by log of 2. And my device is showing x equals 2.807354922. Let's call that a 2.81. You could try with natural log and you're going to get the same thing. Cool. So next example. Same thing, we're going to take the log of both sides. So we have log of 3 to the x plus 2 equals log of 7. And I now know that I can take the exponent and move it down as a coefficient. So x plus 2 times log of 3 equals log of 7. I'm going to divide both sides by log of 3. So we get x plus 1 equals, whoops, that's a 2, log of 7 over log of 3. So type that in. Let's see, log of 7 divided by log of 3. And I got 1.7712, and I'm going to subtract 2 because of this guy, and that gives x is negative 0.22876. So let's call it this. Rounding. And we haven't really talked about where to round to. There I rounded to 2 decimal places, here 3 decimal places. 2 decimal places is probably good. Alright, last one on this page. Before we take the log of both sides, we must isolate the base to exponent. Isolate meaning get all by itself, so we're going to divide both sides by 8 first. Do some canceling. And e to the 2x is 2.5. So some students saw this and they were like, aha, e, I think we should take the natural log of both sides. Yeah, that'll work. Taking the common log would work as well, but let's see what happens. Natural log of e to the 2x equals natural log of 2.5. So yeah, this exponent will come down as a coefficient, but what's ln of e? Natural log of e is just 1. They're reverse processes. This undoes this. So ln of e to the 2x is just 2x. And natural log of 2.5, let's see, calculator says ln 2.5, 0.9162907. Well, yeah, I'll write that. 9 1, 6, 2, 9, etc. And we're going to divide both sides by 2. Round our answer to 2 decimal places, and we get 0.46. Voila! Alright, so in summary, well, next page, but in summary, what did we do? We had questions, equations, where the variable is in the exponent. We simplified a little bit, right here, took the log of both sides, brought the exponent down as coefficient, and then get our answer. So, kind of cool for us as math people that the logarithm is useful in that way. Here's kind of the reverse process where, how do we solve something like? So natural log of x equals 8. So with these, we have a log equation. We're going to convert it to exponential form. So again, this is like log base e of x equals 8. So log base of answer equals exponent. Exponent. Alright. And that's the way it works. So if we were to rewrite this, we would get base exponent equals answer. So e to the 8th, yeah, that's a big number. And calculator will tell us e to the 8. I type it in, and if you're using the TI-85 or something, it'll look like this. Enter, and we get 2980, and let's put in a 2 decimal places, 0.96. Sounds good to me. So similar situation, logarithmic equation, log base of answer equals exponent. Log base of answer equals exponent. Those are definitely in your notes from last week. So base answer exponent, let's rewrite this. Base exponent answer 2 to the 3rd. Hey, wait a second, I know that. And we could add and subtract and get. Alright, sounds good, sounds good. So last example here for part 1 of our lesson. Nice writing here, Tourville. That's a 2. So, looks similar, only we've got this extra stuff. So, PEMDAS, right? We're working backwards. We're going to get rid of the 4, get rid of the addition subtraction first, and then divide by 3. So, subtract 4, 3 log of 2x equals 12. Get rid of the 3 by dividing both sides by 3. So log of 2x equals 4. Now we are in position to convert to exponential form. I wonder what the base is for this. Silly me, that's the common logarithm. So that's a base of 10. So we got base, exponent, answer. Base, exponent, answer. 10 to the 4th, that sounds like a big number, but we can do it. No problemo. 1 with 4 zeros. Oh, that's 3. There you go. 10,000 is 2x, and x equals 5,000. Very nice. So for the questions on this page, excuse me, don't tell your English teacher I said that. We have logarithmic equations, which we basically converted to exponential equations, so we could plug into the calculator. Notice how we're taking the log of the variable, log of the variable, and log of the variable. Oh yeah.